This is a project summary for Team 8 Systems Engineering. Our team members are myself, Sami, Teammates Leader, Client Liaison, Systems Architect and Programmer, Zekun, our DevOps Engineer, UI Designer and Programmer, and Mate, our Researcher. Our project partner is Anne Blanford from the Institute of Healthcare Engineering, otherwise known as the IHE. The problem we're trying to solve is that many courses in the IHE sound superficially similar, which could confuse many prospective students as they do not truly understand the difference between degrees. This causes problems for the IHE staff, as the confusion would lead to a higher rate of students wanting to change courses, which increases the administrative burden on the department. Our solution is to create a decision support tool in the form of a website that helps guide students to choose the correct course for them. Our website aims to do this by asking the users for their details and interests and trying to match courses to this, rather than let the users struggle to find the courses themselves. These are the Moscow requirements we have created to act as a specification for our project. Our requirements are based on both what our client specified as well as what we discovered during our user research. Since this is a proof of concept project, we knew that we would have to do a lot of experimenting with different types of technology and frameworks. So when trying to focus our Moscow requirements, we decided to focus more on functionality rather than gearing it to using a specific kind of software. This would ensure that we delivered software that satisfies the client's wants and the user's needs, while still providing us with the flexibility of being able to choose how we'd want to develop the project. This is our systems architecture diagram. There are two main sections to it. Firstly, there's a Kubernetes cluster that hosts our React front-end and Fast API backend. The cluster is being hosted on Azure's Kubernetes service, which allows the project to be easily scaled up or down. We chose to use React for a number of different reasons. Firstly, it is a well-established front-end backed by Facebook, so we knew that there would be a lot of support and good documentation which we could refer to if we got stuck. Moreover, it seemed easier to learn than some of the other options such as Angular, and React is also quite efficient due to its virtual DOM. However, the biggest reason we chose to use React was because some of our team already had experience with it, so we thought that it would be best to play to our strengths. As a backend, we chose to use Fast API. None of us had any experience in developing a backend, so when we were researching different frameworks, we were attracted to Fast API's concurrency and efficiency, making it one of the fastest frameworks available. We were also attracted by the fact that they had automatic documentation creation, which we thought would be quite useful in our project. The second part is the MySQL database we have hosted on an Ubuntu VM on Azure. The database has been populated with data that we have gathered from two different sources: a web scraper that we have written that obtains data from UCL's website, as well as a student resource called UCL API. We had initially created an Azure MySQL resource, which was working well, but recently we had a problem running this with our Azure subscription, so we switched to using a VM instead.
As you can see from the diagram, we have used a wide range of frameworks and deployment methods. In our React front-end, we use Jest, Material UI, Axios, and React Select. This allowed us to focus on the functionality and not waste too much time with UI design. In the backend, we use the Fast API and MySQL. In order to manage our database well, we used SQL Alchemy, which provides methods that associate user-defined Python classes with database tables, and the instances of the classes with rows in their corresponding tables. We also use the Beautify Soup and request libraries in our web scraper. We also used a variety of testing frameworks in our project as well. We have used Jest to test the React front-end, and PyTest and Test Client to test the backend. We also use a large variety of cloud resources to help with our deployment. We chose to use Azure because of its massive diverse set of resources, as well as the fact that it provides data analysis which could be beneficial later on for our client. For our deployment, we first used Docker to containerize the front end and back end, then used Azure Kubernetes Service to host the website online. We also deployed an Ubuntu virtual machine and experimented with other Azure MySQL resources.
Now for a short demo of our project. This is the URL that currently we can use to access our Kubernetes service. This is our final prototype, which is currently hosted on Azure's Kubernetes service. As you can see, the users are presented with a questionnaire and they can fill out the questionnaire based on a drop-down menu and they select their desired answers. Also, there's some information on how to use the tool and some information on how to answer certain questions. So once the user fills out the questionnaire, all they have to do is press submit, and the front end then communicates with the back end and presents the users a list of courses that are appropriate according to what the users entered. So they're presented with the name of the course, duration, entry requirements, fees, and a link to the website on the UCL page in order to find out more information on how to apply, etc. Also, if the user wants to compare two different courses, they can simply select them. And we created a course comparison card. So this gives extra information such as the course accreditation, a description of the course, as well as different modules that each of the courses have. And you can select multiple, not just two, you can select multiple courses and read through those. Also, you can go back to the previous page and the answers are still saved. This will let the users, for example, change their search criteria if they just want to tweak one or two things, and then they can rerun the search, and our algorithm will produce a new list of courses for them to choose from.
We are extremely proud of what we have accomplished in our project. Not only have we done every single must and should have requirement, but we made sure to build our project in a way that is sustainable, maintainable, and easily expandable, and have deployed it in an efficient Kubernetes cluster on Azure. We have also completed all the could have requirements except for one. We are also proud of the fact that we presented our tool in an Institute of Healthcare Engineering Delivery Group meeting on the behalf of our client, providing us with the chance to showcase our software to others. Finally, we are also happy with the way we have grown and benefited from the project. We have learned many new software skills such as using new frameworks like MySQL, FastAPI, React, and Chest, as well as using cloud resources such as Azure Kubernetes Service. This project has also helped hone our soft skills such as user analysis and requirement gathering, and has helped us improve our teamwork and time management.